In this episode, we move into a part of security that most people interact with constantly, often without thinking much about what is happening underneath. Wireless communication feels ordinary because it is built into phones, laptops, earbuds, cars, tablets, watches, printers, home devices, and office networks, so it becomes easy to treat it like invisible convenience rather than a real security environment. That is exactly why it matters so much for beginners. Because the same features that make wireless technology easy to use also create chances for data exposure, weak trust decisions, and quiet misuse if people do not understand the basics. A wired connection at least feels physically anchored to a place, but wireless communication moves through the air, across shared space, and sometimes between devices that are constantly discovering one another automatically. Once you start seeing Wi-Fi, Bluetooth, and other everyday wireless links as real trust relationships instead of just background convenience, security decisions around them become much easier to understand and much harder to ignore. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A useful place to begin is with the simple idea that wireless means communication without a direct physical cable between the communicating devices. Instead of relying on a wire to carry the signal, the devices exchange information using radio waves across a certain distance and under a certain set of rules. That sounds straightforward, but it changes the security picture in important ways because radio-based communication can be observed, interfered with, or imitated differently than traffic traveling along a cable hidden inside a wall or a rack. The convenience is obvious, since people can move around, connect quickly, and avoid the friction of physical setup. But convenience always changes risk rather than eliminating it. In a wireless environment, location matters, range matters, device behavior matters, and the strength of the trust relationship between devices matters. Security begins with understanding that the air itself becomes part of the communication path, which means the environment around the devices can influence safety in ways that beginners do not always expect. Wi-Fi is one of the most familiar examples because it is how many people access local networks and the internet at home, at work, in hotels, in airports, in cafes, and through temporary hotspots. At a high level, Wi-Fi allows a device to join a nearby network through a wireless access point rather than through a network cable. That access point acts like a bridge between wireless devices and the broader network they are trying to use. From the user's perspective, the experience feels simple because the device sees available networks. The user selects one, and the connection begins after the appropriate trust steps are completed. Underneath that convenience, though, there is a real security decision taking place about whether the device should trust the network and whether the network should trust the device enough to let it communicate. That is why Wi-Fi security is not just about getting online. It is about how identity, encryption, access control, and local network exposure all come together in a space where many devices may be trying to connect within the same physical area. One of the most important beginner lessons about Wi-Fi is that the signal travels through shared space rather than staying inside a sealed path. A home network may feel private because it belongs to one household, and a corporate wireless network may feel controlled because it belongs to one organization, but the radio signal still extends outward to whatever area its range reaches. That does not automatically make the network unsafe, but it does mean the network must rely on proper security controls rather than on the comforting illusion that nobody else can notice it. Wireless traffic that is not strongly protected can be observed or targeted by people nearby in ways that resemble looking through an open window instead of knocking at a locked front door. Even when the traffic is protected, the network still presents a visible opportunity for attempted connection, probing, or impersonation. This is why strong wireless security depends so heavily on authentication, encryption, and thoughtful network design rather than on assumptions about location alone. A wireless signal may be convenient, but convenience should never be mistaken for privacy. Authentication and encryption sit at the heart of wireless security because they answer two basic questions. First, who is being allowed onto the network or into the communication relationship. Second, can the information moving across that relationship be understood by anyone who intercepts it along the way? Authentication is about trust and identity, while encryption is about protecting the meaning of the data during transmission. A beginner does not need to memorize every technical detail to understand the basic value. If devices are allowed to join too easily, the network becomes more exposed to misuse. If data moves without sufficient protection, nearby observation becomes more dangerous because the information may be easier to understand or manipulate in transit. Wireless security, therefore, depends on more than just having a password somewhere in the process. It depends on how confidently the environment recognizes legitimate participants and how well it protects the communication path against casual exposure, interception, and tampering while the traffic moves through open space. Public Wi-Fi brings these ideas into everyday life very clearly because people often connect in places that are convenient but not personally controlled. Airports, hotels, coffee shops, conference spaces, apartment buildings, and transportation hubs all offer wireless access that may be useful, but the trust relationship is very different from the one on a well-managed home or corporate network. A public network is not automatically hostile, but it is a shared environment where many unknown devices may exist on or near the same infrastructure. That means the user should think less in terms of familiar convenience and more in terms of reduced trust. The network might be legitimate and still poorly managed. It might be well-intentioned and still crowded with risky devices. It might also be imitated by a deceptive setup made to resemble the real one closely enough to confuse people. Security in these situations depends on recognizing that wireless access is not just about signal strength and easy internet use. It is about deciding whether the environment deserves trust and how much exposure a device should accept while using it. Bluetooth creates a different wireless picture because it is usually associated with short-range device-to-device interaction rather than broad local network access. People use it for headphones, speakers, keyboards, mice, watches, fitness devices, cars, medical devices, game controllers, file sharing, and many other everyday functions. Because Bluetooth often feels personal and close range, beginners sometimes underestimate its security importance. The range may be smaller than Wi-Fi, but the core trust questions are still present. Devices must discover each other, decide whether to pair, decide what services they will allow, and sometimes retain those trust relationships for future automatic reconnection. That means convenience can again become a source of quiet risk. A device that automatically reconnects, shares more than expected, or stays available for pairing longer than necessary can create exposure even if the user thinks of the technology as harmless background behavior. Security around Bluetooth starts with understanding that short range does not mean no risk. It simply means the trust boundary is shaped differently and usually involves more direct device relationships. Pairing is a central concept in Bluetooth security because it is the moment when two devices begin to trust one another enough to exchange data or services. The process may involve confirmation steps, code matching, approval prompts, or other methods that help make sure the devices are intentionally connecting rather than accidentally or maliciously linking to the wrong partner. For beginners, the important lesson is not the exact sequence of technical steps, but the meaning of the event. Pairing is a trust decision. Once two devices trust each other, they may exchange audio, messages, commands, contact information, health data, or control signals depending on the design and permissions involved. If that trust is granted carelessly or forgotten after the original need ends, the connection may remain more powerful than expected. This is especially important in cars, shared spaces, and workplaces where devices may connect temporarily and then persist in memory long after the situation changes. Good security thinking treats remembered wireless relationships as ongoing trust decisions rather than as harmless convenience settings that never need attention again. Everyday wireless security also includes connections that do not always look like classic computing to new learners. A smartwatch syncing health or notification data, a wireless printer receiving documents, a smart television joining a home network, a vehicle connecting to a phone, a door lock receiving wireless commands, or a fitness tracker uploading activity information all represent real communication paths with real trust assumptions behind them. This matters because modern security is no longer only about laptops and servers in formal office environments. The wireless ecosystem around a person often includes personal devices, family devices, shared household technology, workplace tools, and smart devices that move across different trust zones throughout the day. A phone might use home Wi-Fi in the morning, a corporate wireless network at work, Bluetooth in a rental car, a mobile hotspot in transit, and public Wi-Fi at a hotel that evening. Each of those changes creates a different exposure pattern. The device may still be the same, but the trust environment around it changes repeatedly, which means the security posture has to follow those changes rather than assuming one connection context lasts forever. A common mistake is to think about wireless security only in terms of outsiders trying to break in from a distance. That does happen, but many real risks are more ordinary and more connected to convenience. Devices may connect automatically to remembered networks, accept pairing too easily, stay discoverable longer than necessary, trust old devices that should no longer be trusted, or move sensitive data across environments without the user fully realizing what path is being used. Another mistake is to assume that personal devices and workplace devices are separate in practice just because they belong to different owners. In reality, people often carry both into the same physical space and connect them through overlapping wireless paths. A phone that is both personal and work-enabled may become a bridge between very different trust environments if policies, user choices, or application permissions are too loose. Wireless security becomes much clearer when you stop imagining dramatic attacks as the only problem and start noticing the quieter issue of too much trust being extended too casually across ordinary daily connections. It is also helpful to understand the concept of range in a security sense rather than only in a convenience sense. When people think about wireless range, they often think about whether a signal is strong enough to keep a movie playing or a call connected while moving around. From a security perspective, range also affects who can potentially observe or attempt to interact with the communication. A Wi-Fi network that reaches far beyond the expected area may create exposure outside the intended physical boundary. A Bluetooth device broadcasting availability in a busy public setting may invite connections or probes from nearby devices that were never part of the user's plan. Range does not determine whether something is secure or insecure by itself, but it shapes the size of the opportunity space. The farther a signal meaningfully extends, the larger the surrounding area in which trust decisions matter. That is why good wireless security thinking includes not only who should connect, but also where the communication can realistically be noticed, interacted with, or misused. Another important concept is that wireless does not remove the need for network boundaries and segmentation. In fact, it often makes those boundaries more important because wireless access can bring many device types into the same environment quickly. A home network may contain work laptops, children's tablets, gaming devices, televisions, cameras, speakers, and appliances all using the same airspace, even if they should not all share the same trust level. An office may have employee devices, guest devices, printers, phones, conference equipment, and specialized operational tools, all seeking wireless connectivity for different reasons. Good security thinking recognizes that not every device using wireless should stand on equal footing with every other device nearby. The medium may be shared, but trust should still be segmented according to business need, device type, and data sensitivity. Wireless convenience becomes much safer when organizations and individuals understand that one easy connection method does not justify one flat trust environment where every connected device can see or reach far more than it actually needs. Several misconceptions are worth clearing away because they appear so often in beginner thinking. One is the idea that home wireless is safe simply because it is familiar, when in reality its safety depends on how well it is protected and what kinds of devices are trusted on it. Another is the belief that Bluetooth is too short-range to matter much. Even though short-range communication can still expose private data, enable unwanted device interaction, or preserve stale trust relationships. Some people also assume that a known network name or a familiar device name proves legitimacy, but names are only labels, and labels can be imitated. A further misconception is that wireless security is only about the moment of connection, when in truth the bigger picture includes remembered trust, device behavior after connection, the sensitivity of the data being exchanged, and whether the environment around the communication is one that deserves confidence. Strong security begins when learners stop equating familiarity with safety and start evaluating the trust relationship itself. The reason all of this matters so much in cybersecurity is that wireless communication touches confidentiality, integrity, and availability in very direct ways. Confidentiality is affected because data may move through open space where others can attempt to observe it. Integrity is affected because communication that is not properly protected may be vulnerable to interference, imitation, or manipulation. Availability is affected because wireless communication can suffer from congestion, interference, or deliberate disruption more visibly than people often expect. These three goals help explain why wireless security is not merely about keeping strangers off a network. It is about making sure the right devices can communicate, the information stays meaningfully protected, and the service remains dependable enough for legitimate use. Whether the setting is a home office, a corporate campus, a medical environment, a warehouse, or a traveler using a hotel network, the same broad security goals still apply. The wireless medium changes the form of the challenge, but it does not change the importance of those goals. By the end of this discussion, the main idea should feel straightforward even if the technology around it keeps evolving. Wi-Fi, Bluetooth, and other everyday wireless connections are all trust relationships carried through shared space, not just invisible convenience features that happen to make devices easier to use. That means they deserve the same careful thinking applied to other security decisions, including attention to authentication, encryption, device trust, range, segmentation, and the difference between familiar and truly trustworthy. Wireless security becomes much easier to understand when you see it not as one special technical topic, but as a set of everyday choices about which devices should connect, what they should share, how long they should remain trusted, and what risks are created when communication moves through open air instead of through a controlled physical path. Once that mindset is in place, everyday wireless behavior stops looking trivial and starts looking like what it really is, a constant and important part of modern security.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.